A team of astronomers was searching for something specific and fairly well understood, some of the earliest, most distant galaxies in the observable universe. What they found instead doesn't fit cleanly into any category astronomers had a name for before this week. A single red point of light, dating back to just a few 100 million years after the Big Bang, that looks, at first glance, like an enormous star, except its energy output is roughly 100 billion times greater than any star could physically produce. Rohan Naidu, the MIT researcher who led the team behind this discovery, has been remarkably candid about how unsettled the scientific picture still is. Our picture of this object is evolving very rapidly, he said. This is the real story of what James Webb actually found hiding in the deep universe. Why the leading explanation involves a black hole wrapped inside something that looks almost exactly like a star. And why the researchers themselves think this single, bizarre object might finally help answer one of the most debated questions of the entire James Webb era. I'm your host, and this is your channel. If you want the real science behind the biggest discoveries in space, subscribe now because we're just getting started. To understand why this object caught researchers so completely off guard, you first need to understand what they were actually looking for when they found it. Naidu and his colleagues weren't hunting for anything like this at all. Their project, a survey called Mirage or Miracle, or MOEM for short, was designed to identify some of the earliest and most distant galaxies in the universe, using James Webb's extraordinary infrared sensitivity to look deep into space, and therefore far back in time, at an era when the universe was only a few 100 million years old. The survey's own name hints at the specific problem the team was trying to solve. For years, astronomers studying the earliest galaxies, James Webb, has detected have grappled with a genuine puzzle. Many of these extremely distant objects appear far brighter than existing models predict they should be, at a stage in cosmic history when galaxies shouldn't have had enough time to grow this large or this luminous. Naidu's team set out specifically to determine which of these unusually bright early objects represented real, genuine galaxies, and which ones might instead be some kind of optical illusion, a mirage rather than a miracle, something that only looked like an early bright galaxy without actually being one. While combing through Webb's imaging data searching for promising targets, the team noticed one specific source that stood out as especially unusual, even by the standards of an already strange category of object. It appeared both intensely red and remarkably bright, a combination that immediately raised a familiar, well-understood possibility. Robert Simcoe, the director of MIT's Kavli Institute for Astrophysics and Space Research, and a co-author on the study, explained the standard assumption astronomers typically make when they see this kind of extreme redness. When you see something very red in the universe, he said, you generally assume it's surrounded by dust, comparing the effect to how wildfire smoke drifting into Boston's sky from Canadian wildfires had recently made the sun and sky appear far redder than their true color, because dust and smoke particles scatter blue light more effectively than red, letting more red light through to an observer's eyes or instruments. But when the team looked closer at this specific object's full spectrum, the detailed breakdown of exactly how much light it was emitting across different wavelengths, the pattern didn't match what ordinary interstellar dust should produce. The source was extremely bright at certain wavelengths, and then its light simply vanished entirely. Below a specific wavelength threshold, a sudden, sharp cutoff, rather than the smoother, more gradual dimming pattern dust typically creates. That specific kind of sudden drop-off has a name in astrophysics. A Balmer break, a well-documented feature usually associated with dense gas absorbing photons in the outer atmospheres of stars that are a few 100 million years old. The same basic phenomenon that shapes the spectrum of Vega, one of the brightest and most recognizable stars in Earth's own night sky. Naidu described exactly how extreme this particular break turned out to be compared to anything researchers had previously measured. The break we observed in this object, he said, is the deepest break we have ever observed in any object, a result so pronounced that it effectively ruled out an ordinary star as the source entirely, while simultaneously raising a genuinely strange new question. Were they looking at some kind of stellar atmosphere after all, just operating on an entirely different, far more extreme scale than any known star could produce? There was a second unusual detail buried in the object's spectrum that deepened the mystery further. Its light showed almost no evidence of any elements beyond hydrogen and helium, the two simplest, lightest elements in the universe. No detectable trace of the heavier elements, oxygen, carbon, iron, that typically accumulate inside and around stars and galaxies as generations of stellar life and death gradually enrich their surrounding environment with more complex chemistry. Naidu summed up the overall strangeness of the object plainly. It was truly singular in so many ways, he said, a source that kept failing to match any of the standard categories astronomers already had available to sort it into. Faced with a spectrum that didn't fit any conventional explanation, the research team turned to computer modeling, systematically testing different astrophysical scenarios against what Webb had actually observed, trying to find a combination of ingredients that could reproduce both the extreme redness and the specific deep Balmer break simultaneously. Simcoe described the specific question driving that modeling process. Could you make something appear this red using nothing but hydrogen, without invoking dust at all? To the team's genuine surprise, the answer turned out to be yes, but only under a very specific, extreme condition. If you had an extraordinarily dense screen of hydrogen gas, so dense that it behaved more like the actual surface of an enormous star than like the thin, wispy interstellar gas clouds astronomers typically study, the resulting spectrum could plausibly reproduce both the strong Balmer break and the near-total absence of heavier elements that Webb had actually detected. That still left one enormous problem unsolved, and it's the detail that ultimately pushed the team toward their final, most striking conclusion. Even with a dense hydrogen envelope in place, the model still needed to account for the object's staggering brightness, output roughly 100 billion times greater than what any known star could generate through ordinary nuclear fusion, the process that powers every star we've ever directly studied, including our own sun. Naidu was direct about why this ruled out a stellar explanation entirely, regardless of how extreme or unusual the hydrogen envelope itself might be. You have something that looks a bit like a star but is 100 billion times brighter, he said. That means you can't be powering this by nuclear fusion, which is the energy source that sits at the heart of all the stars we have. Black holes, unlike stars, are genuinely capable of generating energy at exactly this kind of extreme scale through a well-understood process called accretion, wherein falling gas and dust spiral inward toward a black hole, heating up dramatically and radiating enormous amounts of energy before ever actually crossing the black hole's event horizon. With that physical mechanism in mind, the research team added an actively accreting black hole to their simulation, embedded at the center of the dense hydrogen envelope they'd already modeled, then systematically adjusted the black hole's mass and other properties until the simulated brightness matched what Webb had actually measured from the real object. The best-fitting model pointed toward a specific, concrete physical picture, a central black hole with a mass roughly 100,000 times that of our own sun, surrounded by an extremely dense, star-like envelope of hydrogen gas, extending across a region of space roughly the size of our entire solar system. Naidu described the resulting picture in plain terms. There would be this very extended envelope of gas that looks like a star the size of the solar system, he said. It's huge. The team designated this newly identified object MOMBH1, named after the survey that found it, and gave it the working nickname Black Hole Star, treating it as a potential first example of a genuinely new category of astrophysical object, rather than a one-off, isolated anomaly. That framing matters enormously because it connects this single, strange discovery to one of the most persistent, actively debated puzzles to emerge from the entire James Webb era, the mystery of the so-called little red dots. Since Webb became operational in 2022, its deep field surveys have repeatedly turned up small, extremely distant, strikingly red objects scattered throughout the early universe, objects that have remained, in the words of multiple research teams studying them, a genuinely tantalizing and unresolved mystery. Naidu put the broader significance of this new discovery directly. These little red dots seem to be everywhere in the early universe, but essentially disappear by the present day, and what exactly these objects actually are has been one of the most debated topics of the entire James Webb era. The research team believes MOMBH1 may represent an unusually pure, unusually extreme example of a phenomenon that's actually happening much more broadly throughout the population of little red dots astronomers have already catalogued. According to Naidu, every little red dot detected so far is consistent with being a black hole star, embedded inside what looks like an otherwise ordinary early galaxy. What makes MOMBH1 specifically stand out, he explained, is that in this particular case, the black hole star is essentially completely outshining its entire surrounding host galaxy, meaning Webb is capturing pure, undiluted black hole starlight, uncomplicated by the mixed signal you'd normally get from a galaxy's ordinary stellar population blending together with whatever strange object might be sitting at its core. It's worth being honest and precise about exactly where this research currently stands, because that precision is what separates a genuinely credible new discovery from an overstated one. This finding was published in a peer-reviewed study titled A Gas-Enshrouded and Gas-Reddened Black Hole at Cosmic Dawn, appearing in the journal Nature on August 12, 2026, representing real, rigorous scientific work rather than casual speculation. But Naidu's own words, that the team's picture of this object is evolving very rapidly, are worth taking seriously as an honest description of where the science genuinely stands right now. This is a single object, modeled carefully against the best available data, with a physical explanation that fits the evidence better than any alternative the team tested, but it remains, by the researchers' own admission, an active, ongoing area of investigation rather than a fully closed case. confirming whether other little red dots throughout the broader catalog really do share the same underlying black hole star structure will require additional observations and additional modeling work across a much larger sample of objects, research the team and others in the field are already pursuing. What makes this discovery genuinely exciting, rather than simply strange for its own sake, is what it represents for one of the field's biggest open questions. How do the universe's earliest supermassive black holes actually form? And how do they end up so massive so quickly after the Big Bang? A black hole star, if this interpretation holds up under further scrutiny, offers a genuinely new, physically grounded window into exactly that process. A black hole caught in an early, active, gas-shrouded phase of its own growth, wrapped inside a dense envelope of infalling material that mimics the spectral appearance of an enormous star, while actually being powered by something entirely different underneath. So here is where this genuinely leaves things, honestly, grounded entirely in what NASA, MIT, and the paper's own co-authors have published and stated on the record. A survey built to hunt for early galaxies instead turned up a single, red, extraordinarily bright object that doesn't fit into any previously established category, forcing researchers to build and test an entirely new physical model, a hydrogen-shrouded black hole roughly 100,000 solar masses, to explain what Webb had actually recorded. That model matches the data better than any alternative the team could construct, and it may hold the key to explaining the broader population of little red dots that has puzzled astronomers since Webb's very first deep field images. But the researchers themselves are the first to say this picture is still evolving rapidly, exactly the kind of honest, appropriately cautious language that marks the difference between a genuine scientific breakthrough and an overstated headline. If this kind of story is what you come here for, one grounded in exactly what NASA and MIT's own researchers measured and said, rather than exaggeration, hit subscribe and turn on notifications, because there's clearly an entirely new category of cosmic object waiting to be understood. Drop a comment telling me whether you think other little red dots will turn out to be black hole stars too, and share this with someone who still thinks astronomers have already found and named everything strange enough to matter in the early universe.